Alright, so welcome back. In today's video, I want to talk about tree traversal. So traversing a tree means visiting every node in the tree. So we have what we call Inorder traversal, we have Preorder traversal and Postorder traversal. But before we get into that, there are a few terms that I want you guys to understand. The first term that we are going to talk about is what is a binary tree. So a binary tree is a hierarchical data structure in which each node has at most two children. So I'll show you the illustration over here. So this is an example of a binary tree. Each node, this circle here, these are what we call nodes. And so each node has at most two children. So this first node has got 1, 2, this node has got 1, 2, and this node has got 1, 2 children. And these are the nodes at the bottom here. They have 0 children. The most important condition, each node should have or must have at most 2 children. If it has more than 2, then that's not a binary tree. Binary means 2. And so these children that we're talking about, we call them a left child and a right child. So if you look at my illustration over here, this node, let's assume this node is called node A, and then this is called B, this is called C, this is called D, this is E, this is F, and this is G. And so A has got 2, B and C, that's A's children, and B has got D and E, that's B's children, and then C has got F and G as his children. So this has got left and right? These children, B is on the left and C is on the right, and then same with B, it has got left and right, and same with C, it has got left and right. The topmost node is called the root node. So if you look at this tree, it has the topmost node, which is this node here, which is A. We call A the root of this tree. Of course, it's a tree that is upside down, but that's how it's represented. So the root is the first node, and so A in this instance is our root node, which is the topmost node. The nodes below the root, they can either be leaf nodes or internal nodes. Leaf nodes, these are nodes that do not have any children. So if you look at our illustration, which nodes do not have any children? D, E, F, and G. So D, E, F, and G, we call these leaf nodes. They are the leaves of this particular tree. The root is here, the leaves are down here, and like I said, it's upside down. That's how it's illustrated. Anything else, if a node has a child, it might be 1, it might be 2, but at most it can have 2, right? That node is called an internal node. So B and C in this case, B and C are called internal nodes. When we talk of traversal, we have pre-order traversal, we have in-order traversal, we have post-order traversal. When we talk of traversing, we are talking of visiting every node in the tree. We're printing out the value at each node. So let's say this node has got A, and like I say, this has got B, maybe this has got C, this has got D, this has got E and F and G. You can put whatever value you want. You can put letters, you can put numbers. It's all up to you. Depending on what is on each node, values might differ. So for now, we're using letters for illustration purposes. All right, so in pre-order, print out the value on each node when you visit that node for the first time. So first time visit, we print out the value. So how do we traverse a binary tree? We start from the left and then we move to the right. That's how we traverse a binary tree. And so if we are using pre-order, look at the root node. So we start from the root node, which is A in this instance. We print out A because we are visiting A for the first time. We print A, and then we move. Because we are moving to the left first, we look at B, which is to the left side of A, and then B, we are visiting it for the first time, and then we check that node's left side as well to see whether there is something on its left side. So B's left side, it happens that there is a value, there is a C, and then we check C's left side. So in this instance, C's left side, there's nothing. We call this null. There's a null value. There's a 0, nothing, 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 nothing. Right, so these leaf nodes on its left and right, there's nothing, and so we go back to C again, and then we check his right side, there's nothing, and then we go back to B, but B we already have it printed out. Now we have exhausted B's left side. We can now move to B's right side. Now we move to B's right side, we check B's right side, there's a D, we print out the D because we are visiting for the first time. We check D's left and the right, there's nothing, and then we go back to A. A, we already have it recorded because when we started, that's what we did. And so now we are moving to A's right side because we have exhausted everything that was on A's left side. So now we're moving to the right. So we check here, we encountered node E, so we write that value, which is on that particular node, and then we move, we check E's left side, because we always start by checking the left side of each and every node. And so we check that node left side, there's an F, we write that F, and then we check F's left side and right side, there's nothing, we go back to E, and then we now check E's right side. We check E's right side, there's a G, and then it's left and right, and there's nothing, and we go back, and then we terminate. We have finished. And so that's how we do the pre-order. So it's A, B, C, D, E, F, G, just like that. So you can try it out. The way it's applied in code, I will try and use this. So for pre-order, you can define a function called maybe pre-order, and then you print the root data first, you display it, you print the root data, and then you call, usually we use recursion, we call the function root left and then root right. So we print our data first, and then we call our function. We usually use recursion, or we can use loop construct, but recursion is way much easier to use, and so this is how we do it. You print the data first, root data, because we are given the root as our parameter, as our argument in the function, and then you can call the pre-order function to give you whatever is on the root's left, and then again pre-order, give me whatever is on my root's right, and that's it. This is how you apply it in code. I'm not going to be talking much in terms of the actual application in the code. But basically this is the whole idea. In order, we're going to print the value if we visit the node for the second time in our traversal. So the second time we visit that node, then we can print out the value at that particular node. And so what I'm going to do is, please make sure that you have these null values here, so that you don't forget to visit the null values, because it's important when you're illustrating this. So in order, traversal, where do we start? Well, we still start from A, because this is where we're going to start. We're going to start from the root. So we go to root, but we say it's second time, right? So we are visiting A for the first time, so we're not going to print it. And like I said, don't forget this. We always start with the left side, and then we move to the right side. So we start in A, and then we check A's left side. There's a B, and then we need to check B's left side again to see whether there is something at B, so that we do not omit certain values. So we are checking again B's left side, and we see there is a C there, and then we need to check C's left side. There's nothing, and then we come back to C. Whoa, this is for the second time. Now we can print out the C. And then we check C's right side, and then we realize there's nothing, and so we go back to B. And now when we get back to B, you realize that we are visiting B for the second time. Now we can print out the B. And then we check B's right side, because we have exhausted B's left side. We check his right side, we see there's a D, D's right side, there's nothing. And then when we come back, after we check its left side, D's left side, we always come back to D, right? And so we are coming back, and so we are visiting B for the second time. And then we check its right side, there's nothing. And then we go back to B. B, we already have it in our value. And now we go back to A. Now we are hitting A for the second time. Now we can print out the A, like that. And then we have exhausted A's left side. Now we can check the right side. We go to E. E is the first time we cannot print it out. We go to F. Why are we going to F? Because we have to check the left first and then the right of each and every node. And so we check F's left side, there's nothing. When we come back to F, now we can print out the F. And then we check F's right side, there's nothing. And then we go back to E. Now we are visiting E for the second time. Now we can print out the E. And then now we can go to G. G's left side, there's nothing. And then we come back to G, and then we print out the G. And then the right side, and then we go back to A, and we can terminate. So it's going to be C, B, D, A, F, E, G, like that, in that order. So you must keep this in mind. We are visiting for the second time. So basically, this is how we do it when we do in order. The implementation in order, I'm sure it's right here. So you first call the left side recursion, and then you print out the value, and then you call the right side. So you are printing in between. Unlike the pre-order, we are printing first and then calling the left and the right. But for in order, we are saying left first and then print and then right, and that's it. We are now moving on to post order. Post order. So for post order, after you visit the left and the right, then you can print the value at that given node. So in other words, after if you are visiting the node for the last time, then you can print out its value. So let's try and use and apply this with our illustration here. So like I said, I'm putting zeros here for left and right for these leaf nodes that do not have any values, so that I can traverse that part to check. All right, so here we're starting from the root node A, and then we go to B. B's left. I have to say this: we always start with the left, and then we move to the right. So that's why we are going to the left side. And so we go to C. C's left side, we check, there's nothing. We come back to C, and then we check its right side, and then now we are back to C. So like I said, after you finish the left and the right of a given node, we have exhausted C's left and right, and so we can print it out. And then we go back to B. For B, we haven't exhausted this right side, so we cannot print it out. So we're gonna go to D, check its left and right, which is got nothing, and then so we can print the D now. And so when we get back to B now, we have exhausted B's left and right, and so now we can print the B. And then we go back to A. We haven't exhausted A's right side, so we cannot print it out. And so we go to E, and then we check its left side, and then we look at F. F's left and right is nothing. And then we come back to F. You can see we can print F because we have exhausted its left and right. E, and then we check E's. We haven't checked E's right side, so we cannot print it out. We're going to check E's right side. We check there's a G. G's left and right, there's nothing. And so we can now print the G. We have exhausted its left and right. And so we go back to E now. We have exhausted its left and right. We can print the E. And then we go back to A. Now we have exhausted its left and right. Now we can print the A. So the root will always be lost. And so this is post order. The way we implement it in code is right here, post order. Post order, you call the left and the right, and then you print the value. Oh yeah, basically that's it. That's traversal, pre-order, in order, post order of binary trees. If you do have any questions, leave them in the comment section. I hope to see you in our next tutorial. For now, I'm out. Bye bye.